Hello, my name is Ian Watson, and I'm the Executive Director of the American Membrane Technology Association, fondly referred to as AMTA. This is a continuation of our chats with the pioneers, in which we are trying to record for posterity, or maybe longer, the efforts of the early pioneers in the development of membrane technology. AMTA is a technical association that advocates the use of membrane technology for water treatment, ranging from wastewater reclamation and reuse to seawater desalination. The heart of the technology is the membrane. About 2.5 years ago, the board of directors of AMTA decided that we should make an effort to interview as many of the early pioneers in the development of this technology, not only the membrane, but also the membrane systems that came along with it, as a way of preserving the history of this technology. The roots of this technology are in the United States, and specifically in Southern California. And many of the people who worked in the early days live in and around the San Diego area. AMTA's intent is to post segments of these interviews or chats on our website so that the upcoming generation of engineers and scientists understand what went into the development of this technology and its use throughout the world today. With me today I have Ulrich Merten, Bob Riley, Jim Cruver, and Dave Furakawa, all of whom were involved in the very early days of membrane technology, specifically reverse osmosis. And I'd like to start by asking each of them to give us a little background and how they got into the technology in the first place. Ulrich, would you like to give us a little background on your career?
Sure. I was working in the nuclear industry at General Atomic, and our director of research, Ed Kreutz, had some connection with UCLA, went up there and found out what Sid Loeb and Suri Rajan were doing, got interested in it, asked me and Herman Webke, an engineer there, to evaluate it, which we did, decided we were interested in it. We wrote a proposal to the Department of Interior, and in 1962 got a contract which started the General Atomic program in reverse osmosis.
Very good. That's where the name ROGA came from. RO General Atomic.
Yes.
Yeah, very good. Bob?
I was a polymer chemist working at General Dynamics Scientific Research Lab in San Diego when Mert got the contract to work on RO at General Atomic and asked me to join the group, and so I was the first one hired in the RO group under Mert.
And what year was that?
I was with General Dynamics. It's General Dynamics Scientific Research Lab, so it was just a transfer to General Atomic, the same company.
And that was what year?
April 15, 1962.
1962.
Mm-hmm. That was our biggest gift to the reverse osmosis industry, was hiring Bob Riley.
I'd concur with that.
Jim, how about you?
I joined up in a little later, 1969. I had, my background is chemical engineering. I have a PhD from University of Washington. And in the early 60s, I worked for an engineering firm in the LA area. And I loved my job, except I hated LA. So when I discovered San Diego, I figured any way I could get to San Diego, I would get there. But I still had to make a living. And so I took over a project having to do with the power supply for a navigational satellite. And as it was not traditional chemical engineering, I really wanted to get into water or something like that. And an opportunity showed up in 1969 to head up some contracts where they were going to be using reverse osmosis. Now, these guys had already developed some membranes, pretty fine ones, but but then it was the application of how these might be used in the field, particularly in water reuse. So I took over government contracts on that, and that eventually led to Water Factory 21 and some bigger projects.
Dave?
Actually, my career got started in 1960, and I started in electrolysis rather than reverse osmosis, because in 1960, of course, there weren't any really commercially available RO membranes yet. But it was fun testing electrodialysis, and I even tried my hand at a process we developed that was called transport depletion, where we replaced the anion membrane with a neutral membrane to prevent the problems we had in the old days with the anion membrane. But then about 1964, I had the pleasure of testing some of the first reverse osmosis concepts. This was at the Bureau of Reclamation. And I must say that was very rudimentary. Some of the systems were very different designs, and everything from tubular to a flat sheet spiraling type of flow to the spiral wound that GA had developed. And then my involvement with ROGA didn't get started until much later. The company I was working for at the time was Havens International. We were then acquired by Merck, and they then spun us off to another company, which happened to be UOP. And it was run by Jack Hunter at the time. He was a vice president, former director of the Office of Saline Water. And he took over the Havens business. And in those days, it was called Fluid Sciences. And then we realized we needed more than just a tubular design. And fortunately, they were able to acquire the ROGA business from General Dynamics. By then, it was it Shell by then?
That was
Gulf.
I think it was Gulf and Shell.
Shell was it?
Owned it for a while, yeah.
Yeah.
So anyway, then we joined the two groups together. We became Fluid Systems. So that's how my association, thankfully, with Bob got started. And we've had a good time since. It's a long history.
We all have a long history. When you first started to learn, this was work that was being done by Sid Loeb and Surarajan up in UCLA.
Right.
You took a look at that, and where had they got to in the development of the asymmetric CA membrane by then?
Well, they had a membrane which gave, there was Charlie Reed had done this work on cellulose acetate.
Right.
He's the guy that sort of showed that cellulose acetate was a promising material. They cast membranes from that by a technique which ended up giving much higher flow rates than Charlie was able to get. And but that's about where they were. They had a membrane that worked. They put it in small cells, and they were starting to try to build something bigger, like a plate and frame arrangement.
Right.
And when we looked at it, we were impressed with what they were doing, but we identified, I guess, three main things which we really wanted to look at. One was there was no real explanation why these membranes were better, why they gave the high flow rates with selectivity. Secondly, their stuff always sort of decayed with time. That wasn't quite understood. And finally, this plate and frame arrangement looked a little clumsy. So we worked on all three of those problems. And first showed that it was a thin film thing which worked and made these membranes do what they did. Second, we sort of invented concentration polarization, which hadn't really been recognized before, that you really have to mix the water. And then finally, of course, came up with the spiral wound module as a way of packaging membranes more efficiently.
And how did the concept of the spiral wound membrane develop? Who came up with the idea? I mean, were you eating a jelly roll one day and said, "Boy, this is a good idea"? Or?
Well, I don't think any of us can tell you because the guy that originally had that idea was Jules Westmoreland. And where he got it, I don't know, but it worked.
You never know with Julius.
And then that demand, I can remember, Dave, you telling me a story
Yes,
that
might have been true.
and may have been true. You're all sitting around a table and you had this device in front of you and you said, you know, what are we going to do with it now we've got it, sort of thing.
Yeah.
Does that actually happen?
That was actually that was a passed on story, and I think that came from Seymour Kremen, and they were looking for better materials for the product carrier because they couldn't get water through, and he brought his wife's nylons in, and that material became the first try at a permeate carrier, but. There's a lot of that kind of story. I don't know how much they're true or not, but they're good stories.
Yeah, it's the stuff that legends are made of. I always wanted to ask somebody this question about concentration polarization because it's not, at least for me, it's not an intuitive reaction to what's going on in the membrane. How did you discover that something was going on that you needed to deal with?
Well, I think I look back, Bob, great historian here, came up with some of the early reports and even the early proposal. And I looked at it again, even in the proposal, we had apparently already thought of this as a problem. But I think the demonstration that really got us going was taking a little module with membrane in it apart in the laboratory after the flux had declined seriously and discovering that there was a deposit on the surface. And that gave us a clue that something built up on the surface of the membrane.
Yeah. Bob, is it?
It was probably his module.
Did that lead to the concept of minimum brine flows and maintaining velocities and all that sort of thing?
Yeah, actually, Mert published a paper on that very early on all the parameters of concentration polarization, and then later he wrote a book on reverse osmosis, and that was all included in there.
Okay, I shall have to get that. Still in print, huh?
No.
No, but you can get it. Amazon will find you a used copy.
Oh, good. We'll have to get one for the archives, Doug.
No.
Jim, what was your role at Fluid Systems?
Okay, I had several. When I first started, again, I was hired to really manage these government programs on essentially how to use the product. I didn't really get involved in making the membranes so much myself, but it was the idea of how to use it into a system, and to particularly in water reuse was a major market, and one of the issues with water reuse is you're going to have an imperfect feed water system. You'll get membrane fouling. You'll need to deal with the cleaning and such, and so a lot of the work we did was on looking at different foulants and how we might develop fouling prevention, how we could do cleaning. We ran a pilot program at Pomona for a couple of years, something like that. We ran another one at Santee out here east of San Diego to get field data on, and we could try some of our theories in practice, see if they worked or not. Then I'm not sure I have all these years right, but I think it was around 72 or so. We got a grant from the environmental EPA at that point. It was EPA money, and it went to the city of Escondido and the city of San Diego. There was a plant built at the back end of Lake Hodges, right near a shopping center out there now, Winfield Shopping Center, that we actually took the water from that, ran it through reverse osmosis to bring down the salt content. That was the primary thing, because the people were using a lot of water softeners in that area. It raised the sodium concentration way up, and other people used then Lake Hodges for drinking water. So that plant was several 100,000 gallons a day and represented, something that was reasonable size at that time. And it became the model for a 5 million gallon a day system at Orange County, at Fountain Valley. And so that was a successful project. It's no longer, I think it was moved finally down to the football stadium and operated down there. And I don't know what happened to it after that, but so that got that started. Then around 72 or so at that point, the sales were increasing of the Roga elements, also systems, and also they had an international distributor called Ajax International that needed to have a fair amount of hand-holding and such. And the fellow they had as a marketing representative was not very technical. So Ted Larson, who was head of the division at that point, took me to lunch one day. Be careful when your boss takes your lunch, because he said that he thought I should be the new marketing guy. And I said, well, I don't know anything about it. And I've never taken a marketing course in my life. And he says, that's to your benefit. and he says, you know the product, okay? It's easier to teach you marketing after you know the product than teach somebody who knows marketing the product, because he'd been there and it didn't work all that well. So I learned on the job, and we did do well. Our sales went very good. I think it's mainly because we had a good product, but not necessarily as much me. But and also I had some very good people working with me, Randy Truby and his Nussbaum and such, that were immense helps. And so at that point we grew in our sales, and then let's see, 1973 had an opportunity to go over to the Middle East. And if you remember, 1973 was the year that the oil price went up. So it didn't take too much intelligence to realize that you had people over there that needed water badly, and they were suddenly going to get a lot of money. And so that might be fertile territory. And so at that point, we really started working on plants in the Middle East. It took a long time for gestation. For one thing, there's a lot of cultural differences. I spent a lot of time working on learning the language, the culture. Fortunately, in La Jolla was a fellow named Tom Barger, who was the first president of Aramco. And he took me under his wing, told me what to do, and essentially it was really to get to know the people. Don't be pushy, and when the time happens, they'll ask you. And so it took a couple of years, I think, before we had anything really to show for it. And then all of a sudden, it's got a $35 million contract just like that, and changed everything.
Yeah. Dave, what was your role at Fluid Systems?
Well,
Because I actually don't ever remember you being at Fluid Systems personally.
Yeah.
But
it was a short-lived period. Actually, after UOP acquired the Roga division and put us together as Fluid Systems, the fellow in charge didn't seem to think there was much future in tubular systems, and the interest diminished considerably, so I left. That's when I left. But I actually got started in ultrafiltration rather than reverse osmosis. Even though we tried to make a really good seawater membrane, which was, at that time, the most sought after membrane was something that would desalinate seawater At that time, there wasn't much money in selling seawater membranes. So we actually developed an ultrafiltration membrane to separate proteins from cheese whey. And we use that effectively also for separating enzymes from mother liquor, which we could do with our tubular system because it is open channel and you could clean it easily. And we did reasonably well with it. One of the applications I was most proud of was using cheese whey protein and putting it into a fruit drink in South America to combat protein deficiency in those countries. And that work was done by Coca-Cola Export Corporation. And I think we had about 6 fair-sized plants operating in South America for that purpose. And then the enzyme separation is what got Merck interested in the company. And then when we became Fluid Sciences and then combined with Roga to make fluid systems, we remained in the tubular side of the business, but it was rather short-lived. And so many of the folks don't know me well from that era, but we had a couple of really good people come over to us from the spiral business, Jack Luce, for example, one of the great guys in the business. And of course, that's when I was able to work with Bob a little bit, and that grew into an even better relationship further down the line with Film Tech Corporation.
Right. Right. When you started with the membrane development, obviously using flat sheet and cells, and then you developed the spiral concept, what drove the selection of 4 inches, the size you should make?
What was 4 inches?
Or was it something you could fit in a 4-inch pipe?
If you're talking about the outside diameter
Yeah.
of the module, I'll bet it had more to do with the size of pipe which is available than anything else.
Yeah,
I mean, one of the great things about the spiral system is that you can use an ordinary piece of pipe as your pressure vessel.
Right.
And so whatever you had. But of course, the thing about the first concept of the spiral module is that when you wrap this sheet around and around, pretty soon you get to the point where the pressure drop on the side where you're collecting the water is too high. The water has to flow through the spacer and get all the way to the central pipe. So that's why, the first spiral wound module was a single wrap, and this most important modification was, one, realize that you can put multiple wraps in there, and then perhaps equally important, that you can devise a way to make all those wraps from one length of a membrane sandwich,
right.
Wrapping it up, folding them as you go. Then you have something which you can manufacture, which has a high membrane density and fits in a round pipe.
That was when you went from a single leaf to multiple leaves. How many were there in a typical 8-inch membrane in those days?
Geez, I don't know whether there's a typical number you could say.
Because there's, 30-odd now in an 8-inch membrane, isn't it?
I think
even more than that.
as the flux in the membrane went up, then there was impetus to do more leaves.
Right, right.
And if you had a low flux membrane, then you didn't need as many. But
Right. Yeah. Who was, when you first started actually making making membranes on a commercial scale, did you have any other competition in the spiral market? Was anybody else doing it?
I don't think so.
No.
So you were really competing with DuPont?
No. Well, Well, for the
I mean, not competing the spiral, but competing for the membrane market, such as it was then.
what we were really competing for was the government contract market.
Some things never change.
I think
And the
you're
main
competing
competitor,
for somebody doing something.
Right.
and the main competitor for that was Aerojet General.
Ah,
And
yeah,
they were-
the Virogenics.
Right.
And they were working on the plate and frame concept
Yeah, yeah. But then they went into spiral wound membranes
did.
later on.
Later on.
Virogenics.
much
yeah.
later on.
Yeah.
Probably not a story I should tell, but I will. I once was in Washington, D.C., and off the City and Water meeting at which there was also an executive of Aerojet General present. And he had a limousine, and he offered me a ride back to the airport. And so I took it. And during that ride, I learned two things. I learned that Aerojet had decided that the plate and frame system was not a good system, that they were going to change to the tubular system, and that the second worst possibility was the spiral wound module.
But yet they were the first ones to rip us off.
That's good. That's good.
Yeah.
Well, Jim, when you left Fluid Systems, as I recall, you went into the ultraviolet business.
Right, I did.
Which was quite a departure from membranes.
Right. Well, a couple of things really influenced that. One is that I had a chance to meet a fellow here in San Diego named Al Landry, who no relation to the coach or anything, but he had some patents for using Teflon as a barrier in UV, which seemed very attractive to me. And so the other thing was that I'm a latent entrepreneur, always have been, let's say, and I came out of the closet that year. And and I also had a daughter who was 8 years old at that time, who was getting a little tired of me traveling around the world and leaving her. So there were three things there that kept me in the home, kept me around to start that business. And so we actually formed two companies, one called Salcor. My wife is Sally, my daughter's Corinne. I just put the names together. And the other one, Ultraviolet Technology. The reason for two companies, I had partners in the other one. And then we sold that off in the 1980s. And then I continued Salcor. And actually went back into the ultraviolet business in the 1990s. Had a couple of ideas. The old original patents had run out in 1989. And so I didn't pursue that further, but came up with some other ideas on ultraviolet, and we're still doing it. And all my intelligent friends have retired. Well, not all of them, not Bob. Some of them have. But I find it's quite exhilarating to run a small business. And so we manufacture and sell small UV devices for waste treatment, essentially for taking water that has been through a waste treatment process, secondary treatment type process, and these are passive systems. They don't require a lot of cleaning, which most UV do. This can be cleaned once a year, and the lamps change every other year, so they can be used in individual homes and small systems. And we have, 60, 70,000 of these out operating.
Huh.
So,
Good.
And at the same time, actually on the same day, came up with the idea to use it for food, fruit juices and that type of thing, which are opaque to ultraviolet. And essentially you only get a penetration of maybe a couple of mils through the juice. But if you use turbulent flow on a long flow path, then eventually you renew that surface enough so that you can get approach sterilization. So I took that through, got it approved by FDA, and so we're doing that as well, primarily for health food type producers.
Interesting. So quite a ways removed from membrane
Yeah, it's been a while
technology.
since I've done anything with the RO. But
Dave, when did you go to Film Tech?
Oh gosh, I was their initial consultant in 1978.
This was right after you left Fluid Systems?
Just about. There was about a three-year span there. But that's when they were developing membranes in John Cadot's garage. And so I helped them primarily with their product strategy, because you have to start small and work your way up to the bigger systems, and also help them develop some of their markets for the product. And then I joined them finally in, it was about 1983, I guess it was, as a vice president, and stayed with them through the Dow acquisition. And when that contract was finished, I left. It was, I guess I'd say the corporate culture was too much of a shock for this guy. I'll just leave it at that.
Yeah. That was in, when was that? That patent was issued like 76 or something like that? The the FT30 patent?
The FT30 patent was issued
76, 77, something like that.
it was either 78 or 9, I think.
Yeah.
Yeah, and they started selling their first membranes about 1980.
Yeah.
Yep.
Yeah. And at that time, you had already developed thin film composite membrane.
Right.
And an early version of that was what was loaded into the Jetta seawater plant.
Right,
Is that
right.
correct?
Right.
Yeah. Yeah. What did you think when this upstart group up in the frozen north came along with a membrane that was
Well,
possibly going to challenge you guys?
well, John and I were good friends, so we met quite often, and I recognized he had a good membrane, so I brought him to Fluid Systems and tried to create a marriage between them and Fluid Systems, but our general manager at Fluid Systems didn't see any merit in the FT30 membrane, so the rest is history.
I guess I was at Sanibel. I'd left Hydronautics, and we put a 2.5 by 20-inch Film Tech element up on a piece of plywood and ran it parallel to Train A for years. I don't think we ever had to clean it. I don't think the flux ever changed. So when I went to work for Hydronautics, I said to Jim Bartlett, you really should take a look at this. I said, you may want to buy this company. He said, I don't think they'll ever do anything. He said, it's too expensive to make. And at that time, of course, Hydronautics had nothing but CA in those days. So.
Well, at the time, Larson actually wanted to join with Fluid Systems, but our general manager just didn't have the vision.
Yeah. Now, Ulrich, how long did you stay with Fluid Systems before you moved on to other things?
I never was at Fluid Systems.
You were always at Roga.
I was always with General Atomic, and in '73, Gulf was the owner at that point, and I moved to Harmarville, Pennsylvania, to head a division of Gulf Research and Development Company. So that separated me from the reverse osmosis business.
Ah, okay. But you were involved in the peach bottom reactor?
My early time at GA was mostly spent on the Trigger reactor, which is the development of fuel elements for a research reactor. And I did a little bit of work on the high-temperature gas-cooled reactors, but not much. And what I migrated from doing development work was becoming sort of an administrative tool in the research business, and that's what moved me from GA to Harmarville.
So, as you look back and you've seen what's happened in the RO business since you were at Roga, has it fulfilled your expectations or exceeded them, or do you think we could have done more?
Well, I think it's done pretty well. When we started it, the nuclear industry was at the peak of enthusiasm. And what we foresaw was an infinite supply of almost costless energy. And the question really was, what are you going to do with all this stuff? And I think what sort of got us interested in things like reverse osmosis was to go out and irrigate the deserts. And I don't think we've quite got to that point yet.
Yeah, that was one of the wasn't that one of Kennedy's comments early on with the Saline Water Act? We're going to make the deserts bloom.
Yeah.
Not quite there yet, but working on it. The helicopter.
Okay, great, thank you.
So,
That's incidentally a pretty good memory of days at General Atomic, because General Atomic then and now is under the flight path for Miramar Naval Air Station, and so we are very accustomed to the little pause in the conversation while the plane goes over.
Towards the end of the fluid systems business, did that decline because there was less enthusiasm for being in the systems business, or was it because you couldn't compete with some of the smaller guys who were starting to emerge and compete?
I think it was mainly because we found ourselves competing with our own
With the
customers.
yeah.
And that's really why the decision was made
Yeah.
to get out of the systems business.
It's the same reason Hydronautics got out of the systems business. Yeah. The development of the 12-inch membrane for Yuma, and we've talked about this earlier. No, we haven't talked about it. I've talked with other people about this earlier. Having come to the conclusion that for a large project such as Yuma, a larger diameter membrane would be of value, why didn't Fluid Systems continue to promote that?
Well, I don't think at that time plants were, Yuma was the largest plant at 100 million gallons per day, and that was the only plant that really justified going to that size at that time.
Yeah, but there were some larger plants being built in the Middle East.
Yeah, I guess
Buaib, I
that's
think,
true.
was 15 million gallons a day or something like that. That's always, and then now we have a large format membrane at 16 inches.
Mm-hmm.
So it seems like a step forward that fell on deaf ears, if you will.
Mhm.
Was it difficult to make a 12-inch element?
Well, it's more
Scale up-
it is
scale
more
up?
difficult
Yeah.
to make them to high yield. It was at that time. I think it's improved quite a bit
Yeah.
in the last few years with automation and all. But yes, it was more difficult. And then also we never got the running experience at Yuma on those 12-inch elements because the plant never was in full
Never really
operation.
operated, right.
So never really knew how well they,
And will it ever?
and will it ever, yeah. But more recently, it has run periodically for short periods of times, and
Yeah.
they're still running
Yeah.
well, even though those membranes are 30 years old.
That's incredible.
It is incredible.
That is
Yeah, it is.
incredible.
It's amazing.
So when you left Fluid Systems, what did you do?
Well, I've worked with Dave for a while with Filmtech for a couple of years, and then after that I started my own business, Separation Systems.
And you're still doing membrane development work?
Yes, same.
Any secrets you want to share with us?
I don't have no secrets.
No
I don't have any secrets. Still doing government contracts, so it's still out in the open.
Yeah, but it's getting tougher to get government contracts.
Yes, it is.
Yeah, it is.
That's
I'm
for sure. That's for sure. You think the new technologies, or so-called new technologies, I remember Sid Lowe wrote about forward osmosis even when he was doing the work at UCLA. And nanotechnology, modified membranes, do you think that they're as good as they're cracked up to be? Do you think there's a niche for them? Do you think they're going to eliminate reverse osmosis altogether, or do you think they'll disappear?
Well, we have worked on forward osmosis off and on the last few years, and no, I don't think it's going to replace reverse osmosis. And I think right now it's mostly hype, and we don't have a membrane that functions well in forward osmosis, and it's not clear that the economics are really there. Yeah.
I guess the attractive selling point is that, at least to the layman, is that you're using the natural osmotic pressure of the water, and you don't need to add anything. But at least on the municipal side, you got to get the water back out of the draw solution, and that's going to take some energy.
That's right.
Yep.
Right.
So it took energy to put it into the draw solution. It's going to take it out.
Right.
And you also have to have the membrane. Right now there's a lot of people working on forward osmosis, a lot of hype, but there's no membrane. The membrane has to be very thin so you don't have concentration polarization in the back side, because you have a salt solution on each side of the membrane.
On the mixed side of the membrane.
So you're almost forced to go to hollow fibers.
Right.
And hollow fibers are very thin thicknesses. And we're down to 30 micron thick wall at the present, but we still have polarization.
And hydration technologies actually uses a cellulose acetate membrane.
Right.
Then. And they've been around for a while. I'd never heard of them until I read an article in a magazine about some project they'd done for a golf course in Arizona or something like that. And all of a sudden they become like the darlings of the game. What about nanomembranes?
Well, there's been a lot of hype on nanomembranes as well, and the biggest player there is Nano H2O, and they've had a lot of venture capital money put into them, and you still don't see them really competing with Dow or Hydronautics, so it's been quite a while. They've been working on them, a lot of money, but they're still not there.
Jim, are you sorry you left the membrane business, or have you had such a good time with UV that you...
No, I'm not sorry.
Or you had such a good time being an entrepreneur, I should say.
I think that's a lot of it right there.
Yeah.
Well, it's hard to say. I have to go back and try that one in an alternate universe. I think I certainly enjoyed my time there, and certainly enjoyed the people I met and the whole vibrant technology. I think at the time I was wanting to. I was seeing at that time the let's say more of a maturing of that, and I saw a chance on the UV to be right on the cutting edge.
Right.
And which we were. In fact, we were before. Probably should have waited about 3 or 4 years to get into it. Because we were ahead of our time, and had to go out and sell people on UV itself, which again, I remember those days in reverse osmosis. You had to spend half of your talk on explaining what reverse osmosis was before you get into the details of why yours was better.
That's right.
And now UV is certainly not as big as RO was, and I think as our objective right now, I have no desire at my age to start some big company or anything
I
like
thought you were
that.
going to get ready to start something else.
Yeah, keep it small, and if there is something that you could spin off or something like that, that's fine.
Yeah.
But certainly have no grandeur of building a large organization. And so though we do a lot of traveling, and that is one advantage or disadvantage. But my wife goes with me, and so that's an advantage.
Right.
And
Right. Dave, since you left Film Tech, you've done some interesting things, I know. And was a stint with the South African company
That was interesting.
was doing some
yeah.
interesting stuff.
That was interesting, yes. It was a time when there hadn't been much movement in improvement of spiral wound technology or RO, and they had a device I thought held promise, and it was the use of an electromagnetic force to create more movement in the ions, which ostensibly would help with a number of things, including with the concentration polarization layer at the membrane. So it had promise. Unfortunately, I don't believe there was sufficiently good management in the company, but that was as a consultant, that was an interesting assignment. And I must say that after leaving Film Tech, I probably enjoyed myself more in helping to develop organizations like the National Water Research Institute, which Ron Linsky formed about 1995, I think it was. And, it was a real pleasure to work with Ron. And unfortunately, he's no longer with us, but he was just a superb gentleman and tremendous force in organization. So, and my time with NWRI has been very pleasant. I'm still chair of their research advisory board, on which we've had some great people, Bob Riley included,
Right.
Perry McCarty, and some of the other luminaries in our business. So to me, that's been tremendous. Then about 1996 or so, Ron and I traveled over to Muscat, Oman, and on behalf of the U.S. Department of State and the Ministry of Foreign Affairs in the Sultanate of Oman, laid the foundation for the Middle East Desalination Research Center, which was one of the 5 legs of the multilateral peace process.
Right.
And to think that water technology or research could play a part in the international politics going on at that period of time was a tremendous thrill. And we got to work with so many people from different organizations. To me, that was very fulfilling. And now, most recently, with the National Center of Excellence in Desalination in Australia, I've reached new ground. A very different approach. Australians have taken on approach to all things, and desalination is one of them. They enjoy, at the moment, the notoriety of having built probably the 6 of the largest plants in the world in the last, since 2006.
Yeah. 6 years.
6 years.
Yeah. And Melbourne just started up, I understand.
Melbourne just started up.
Yeah.
So they have a tremendous passion for the technology and the ability to make things happen.
And you learned a new language.
I did, mate. But it's been a very fulfilling job for me. I've really enjoyed helping them build this center of excellence. We now have 44 research projects underway on a good number of different areas of desalination. Like Bob, I don't believe anything's going to come along anytime soon to replace reverse osmosis. I mean, it's It's a tremendous process. But we are working on some novel processes that show promise. As you know, Ian, we've had many along the
We've
way
had many
that have
along
shown
the way.
promise.
That's right.
Yeah, but some really good approaches. And one of the things that we are also doing is that we are adapting desalination technology to some of Australia's unique circumstances. For example, communities off the grid
Right.
that have to use renewables for any new chores, and in some places they still use diesel generation. But you know, when you are 12 or 1,300 kilometers from Perth, it's very difficult to service something like that. So, trying to come up with an adaptation of current technology that will allow you to develop a robust system that will work on renewables is a real challenge.
Yeah.
And we're right in the middle of that right now. So to me, it's tremendously exciting. As well as trying to solve some of the problems that still exist with membranes that were here 20 or 30 years ago. Membrane biofouling, for example.
Yep.
Still with us. So many people are working on it. Tony Fain at Singapore Membrane Technology Center and Gary Amy at KAUST, as well as our center. We're all working around on this problem of membrane biofouling, as well as the Dutch group Wetsis and many others, for that
Yep.
matter.
Yep.
There are probably more funds are being expended on solving that membrane biofouling problem than any other aspect around the globe. So it's a nice mix of things that we're working on, and it's been a pleasure. And the Aussies, indeed, have been a pleasure to work with.
Good. Good. Well, Ulrich, it's as the gentleman who wrote the first proposal to the Office of Saline Water to develop the spiral wound membrane, it's been a privilege to meet you. And I thank you for coming here today. Bob, as always. Jim, thank you for coming.
Thank you.
Even though you are a traitor to the cause and went to the UV side.
Not
Can we call that the dark side? And Dave, as always, and I know you didn't fly back from Australia specifically for this, but I know if we'd asked you, you would have. So, thanks very much, guys. I really
Thank you.
appreciate it.
Thank you.
Thanks, Ian.
Thank you.